So let's discuss another atomic property which is known as electronegativity. But then don't forget, I still remain Tutor Prince Obajo Daniel Dinicol, also known as the Mathematical Arithophysical Biologist. So, what is electronegativity? Electronegativity is the ability of an atom in a molecule to attract electrons to itself. Yes, the ability possessed by an atom to attract electrons to itself is called electronegativity. But then we need to know the fact that electronegativity increases across a period. Yes, and also it decreases down the group. Now, how do we know that, or how can we be convinced about that fact? Let us consider some period 2 elements such as nitrogen, oxygen, and fluorine to attest to that fact. So first of all, we need to remember that sodium, what's it called? Nitrogen has atomic number of 7. On that note, the electronic configuration with respect to shell diagram is 2, 5. If you draw the shell, you are going to have 2 electrons in the first shell, and in the last shell, which is the second shell, we have 5 electrons, as you can see presented here. What about oxygen? Oxygen has atomic number of 8. On that note, the electronic configuration with respect to shell diagram is 2, 6. So we have 2 shells as well. Remember, the number of shell drawn actually depicts the period an element belongs. So we have 2, 2, 2. Now the last one there, which is fluorine, has atomic number of 9. On that note, we are going to have still the same number of shell. 2, that's 1, 2. The second shell, we have 1, 2, 3, 4, 5, 6, and 7. Now remember, I said electronegativity increases across the period. Why? If you look at the number of shells we have for each of these elements across this period we are dealing with, the number of shells is the same, 2. But then looking at the number of electrons we have here, we have 7 electrons for nitrogen, 8 electrons for oxygen, 9 electrons for fluorine, which means we have 7 protons also for nitrogen, 8 protons for oxygen, 9 protons for fluorine. Now, looking at the trend of protons from nitrogen to fluorine, you will notice that there is an increase in the number of protons. And remember that when there is increase in the number of protons, the protons in the nucleus tend to attract the electrons to themselves. That is, there will be higher nuclear charge across the period. On that note, since the protons tend to attract electrons to themselves across the period, it means they will easily attract electrons to themselves. Are you following through? That is, if another electron is meant to be added, they will easily grab the electrons since the nuclear charge is very high. Since the protons in the nucleus tend to attract the electrons they have to themselves across the period, as you can see there. On that note, we can agree that the electronegativity increases across the period. But then, how can we be sure that electronegativity decreases down the group? Now, let's consider 2 elements from the halogen family, that is fluorine and chlorine. Let's consider fluorine. Fluorine has 9 electrons. So drawing the shell, we have 2, 7, as you can see it presented here. And chlorine has 17 electrons. So distributing that based on its electronic configuration, shell-wise, we have 2, 8, 7. That is 2 for the first shell, 8 for the second shell, and 7 for the last shell. Remember, the valence electrons, that is the number of electrons found in the last shell, determines the group. So we can say this fluorine and chlorine belongs to group 7, since the number of electrons we have at the last shell is what, 7. Now, why can we agree that electronegativity decreases down the group? Now remember that we said, now comparing these two shell diagram, you notice that the number of shells we have for fluorine is 2, while the numbers of shells we have for chlorine is 3, which means that chlorine electrons move further away from the nucleus compared to fluorine. On that note, fluorine, the protons in fluorine we tend to drag electrons more closer to themselves than that of chlorine. On that note, fluorine will easily attract electrons to itself. Are you following through? While chlorine will the ability for it to attract the electron will be lesser in comparison with fluorine. I believe you understand. What I'm trying to say is this. Looking at the shell diagram for fluorine, we have 2 shells. Looking at the shell diagram for chlorine, we have 3 shells. The electrons in the shell tend to move further away from the nucleus because the atomic radius of chlorine is larger than the atomic radius of fluorine. On that note, the protons of fluorine tend to pull more electrons to themselves, and therefore will be readily available for them to attract electrons to themselves. On that note, looking at the shell diagram of chlorine, the electrons tend to move further away from the proton because of the distance between the protons and the what? The electrons. On that note, this chlorine will find it difficult to attract electrons to itself when compared to fluorine. So as we move down the group, the electronegativity of the element decreases based on that fact.